Okay, 31203 mechanical component design. Okay, instruction. This is a group-based design project. Student caught for plagiarism will be given 0 for the project. Okay. All right. Explanation about this project. Okay, the design project is one of the important aspect. Okay, so total 40%. Okay. So this project is based on the project-oriented problem-based learning activity. Okay. So at the end of this project, students will be able to improve their technical report writing skill with ability to justify the design project, inform a report, perform and present design calculation, and also present the outcome of the design in the form of engineering drawing. Engineering drawing. So again, you need to refresh again your skill in produce technical drawing using SolidWorks. All right, the project will be carried out in group. Okay, 3 to 5 members. Okay. Themes of the project is designing a gearbox. So our focus is you need to design a gearbox system. Gearbox system. So actually we just start learning about gearbox. Okay. We just start learning about gear last week. Okay. So the idea is to produce the gearbox system. Okay. So there are 4 areas, 4 type of machine, which are sugarcane, ceiling fan. Sorry, not 4, 3. Sugarcane, industrial ceiling fan, or Dremel machine. Okay, so there are 3 options. Okay, so so the idea is to produce this gearbox. Okay, application on sugarcane, industrial ceiling fan, or Dremel machine. Okay. Students must analyze all mechanical components inside the gearbox, such as shaft, bearing, gear, in terms of their strength, static, fatigue, safety, reliability, dynamic motion, life estimation. So if you go to the report just later on, you will get some more understanding about what to do and how to do. And finally, student need to come out with engineering drawing. Okay, all right. So the report 40%. So 35 on the final project report and 5% is on the lifelong learning skill. Basically, this one on the technical, on the SolidWorks drawing. Okay, example of gearbox. Okay, all right. So we learn about basic of gearbox, about the gear last week. So this is example of the system, gearbox system. Okay, you have maybe there will be a gear, pinion. So you can see there are 3 shafts. So maybe this is considered as there are 2 sets. Set 1, set 2. So this may be a shaft that attached to the motor. So example of industrial ceiling fan. Sugarcane machine and trommel machine. All right. Okay, this is the project report, the draft. chapter 1 about the introductions, the detail is there. The second chapter, the core, which is the design and analysis. You need to calculate all those fundamental analysis, gear failure, shaft bearing analysis, housing, and lastly produce the technical drawing, conclusion and recommendation. Okay, so this is an example of a Gantt chart. This is assessment on the report, report, very detailed. And this is on the rubric marking criteria. All right. Okay. So this is an example of group organization. Okay. You have this logo, name of the group. Or for example, is a grease monkey. Okay. The other one. Third example. All right. Okay. So if you open the report, example report, the password. So the password is the code, subject code. Okay, this is example of the report. Okay. Group members, this is the airport baggage conveyor. Okay. Right, you can go through. So, okay, as mentioned just now, introduction. Okay. So introduction, okay. Introduction is about group project. Sorry, about group description, about the product, about the objective design scope, and about the Gantt chart 1.4. Okay. All right. Okay. Product explanation about the product. Okay. Some literature review. Get some ideas about the product that you want to develop. Okay. How the system working. What conveyor, gear background. So no need. Okay. Example, this is a conveyor, system conveyor. Okay, the important is the system. Okay, the size, and most important is what is the standard motor. Power to produce, power to run the system. For example, this one is 1.5 to 4.4 kilowatt. All right. And then this is how you're going to calculate the power actually. The power. Okay, you got all the information. Conveyor total weight. Total weight, total speed, you get the torque, and finally you able to produce the power required, and then from there we select motor from the catalog, okay. That's one, that one for chapter 2 lah. This is the sketching. Change so you can just go through and then okay, so fundamental analysis. So okay, just go through first. In the same time, each of the topic we will cover in the subtopic lah, in the chapter. Let's say gear, how to calculate the shaft, how to calculate the minimum diameter, for the shaft and so on. And this one, the power required by motor 4.6. Okay, so you need to select the motor that at least 5 kilowatt. The example lah, brand of motor, Victor Motor. Mesti using at least this company, this group select 4.5 kilowatt. Alright, you can go through whatever all this thing how to create. So basically every weeks. So this week you perform the group. You create a group. Okay. So I will create author here. Group activities. So group activities. Group project. Okay. Section 3. Section 3. Group project. Right. About 40. 40. So group 1. Okay, so sorry, group 1, I should put maximum 5, 1. So group 2, still forward. Group 3, group 4, eh 5 kali 5 25. Satu section ada 40 orang. 40 mana 8. 8 kali 5. 8 kali 5. 9 grup So group 5. Six. Alright, sudah dia masuk uh, 7.
Doktor, nak tanya boleh?
Yes.
Ikut section ke boleh campur section
Uh, Before this, ada yang request good friends in the different section. 40 40 maknanya kejap So total student 40 80. Okay lah, okay, you can you can mix the section. It's okay. You can make the section. The issue is okay, never mind. You can make section. I just later on I need to figure out how to set up this. I think I need to add all the students under session 3, session 4.
Okay, Doctor. Thank you, Doctor.
Okay, 7, 8. Sembilan. Okay, I will create a group in the author later on because it is takes some few minutes, few time. Right. Okay. 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 Now week 6. 7. Alright. 7. Okay. By next week. Okay. I wish everybody have the group, and then on week 8, week 8, 8, 9, 10, 11. 6 weeks. Okay, 6 weeks. Okay, so start on week 8, right? Start on week 8. Okay. Okay, so we will have appointment on group progress. Okay, start on week 8. We will have a group progress. So I will open the slot, and those groups ready, and then we will discuss later on about the important area is okay. Each group able to my aim is able to decide what is the gear ratio. Okay, what is the gear ratio Okay, so basically, okay, this is an example of the gear set arrangement. Okay, student, the group, every group able to decide what is the basically what type of motor, size of gear, and so on. Then I satisfied, then you can proceed with all the next calculation. This one of the purpose to avoid plagiarism. We will have a weekly meeting on group progress. Okay. Any question regarding the project? The report, that one is under. Okay, this one, if you refer to this, okay, this one, you refer to assessment, Okay, assessment. Okay, that one is under this one, bonus, you able to follow the format, have a table of content, content organized well, and report is binding properly. No need to send hard copy lah, but this is that one. You refer to footer, sorry, this one, footer. That one is considered under this one lah. Well organized, that one well organized. You got extra bonus mark lah. Okay, so the important is you form the group and then you select your tema untuk you punya project lah. Okay. Alright. Okay. Give me 5 minutes break and then we continue our lectures. Alright, we continue. Gear part 2 Right. So on the RPP week 6 brief project briefing just now discussion on the group project, example group project, right? So group registration, you can later on register in the author. In the meantime, you can try to find your best friend to form the group. Later on register. Okay, part 2 gear part 2 So week 6 and week 7. Okay, gear part 2. Okay, are you ready? Okay, okay, the learning outcome for this part 2, students will be able to apply, do some calculation, analysis, find the safety factor, okay, of spur gear, spur gear. We focus actually on the spur gear, to find the safety factor, respect to failure, respect to failure. So there are two types of failure, which are bending and pitting. Okay, bending and pitting. All right. Okay. So gear failure, right? Okay. So as usual, I need to write down something so that get familiar. What is the my mapping of my lectures? Okay, gear analysis gear part 2 lah gear part 2. Okay, gear part 2. Alright. Okay. So basically okay, there are two type there are two type of failure there are two type of failure. Okay, gear failure, the first is bending, bending. For gear, first bending, second one is bending pitting, pitting. Alright, pitting. Okay. So what is bending? What is pitting? Okay. So explanation is there. Bending, bending crack lah, crack. So the definition is the stress equal or exceed the yield strength. All right, that's the fundamental of statement. The stress that acting on the gear is equal or exceed the yield strength of the gear, the strength of the metal, the strength of the properties of the gear. Okay. While pitting, okay, stress equal exceed the surface endurance, surface endurance and bending endurance. Okay, okay. So it's good to give you more about the pictures of bending failure, gear bending failure. Okay, what is gear bending failure? Gear bending failure. Okay, we focus on we will see the pictures, to get more understanding. Okay. Okay, so these are categorized under bending failure. This one, bending failure. See, the crack happen on the gear. This is okay. This is considered as a gear bending failure, right? This one. And what is gear fitting failure? Fitting is on the surface. So what is it? Fitting. Alright. Okay, this is considered as fitting. Surface chip off. This is fitting. You can see, surface chip off. Okay, that's considered fitting. Fitting. So this is bending and this is fitting. Alright. So two type of gear failure just now. Bending failure and surface fitting failure, or we call as just fitting. Okay. So this one, okay, gear standard quality, ACMA is American gear, BGA British gear, Japanese JG, Europe Eurotran. Okay, so every continent they have their own standard. Similar to Malaysia using SIRIM. Right. Okay. So two type, bending and fitting. All right. So how to calculate the safety factor? How to calculate the safety factor? Right. Okay, it's very simple. Okay, you just keep all those information. Later on, we will back to every slide. So we just jump to the last page of this chapter part 2. Part 2. Just straight go to page 55. All right. Okay. Okay. So bending. Okay. This one bending. Okay. So the safety factor. Right. FOS or factor of safety factor. Okay. Okay. So FOS, factor of safety. Okay. What is this? This one. The equation to find the safety factor is SF equal to this one. Page 55. Is it similar to your student note? Is it page 55?
Sama doktor.
Ya dokter sama.
Oh, page 55. Okay. Page 55. And then for how about fitting? To calculate the safety factor or factor of safety. Okay, is using the next page is using SH. So SH. SH equal to whatever is on page 56. Okay. All right. Okay. So I made some copy, simple gesture from a famous TikTok, Kabilame. Okay. All right. So your gear part 2 is This one. Huh? Simple. Eh? Okay. So we have a problem to find. Okay. So let's say find the safety factor for the gear. Okay, if you still remember, if I make a sketch from last week, example, aku tunggu dia. Okay, so let's say we have this system. Okay. Okay. So let's say this is a motor. So this number 1, number 2, number 3, number 4. Okay. Can you understand this simple sketch here? Anybody don't understand? Okay, this is referred to
Gear.
Gear, gear, So refer to gear, gear. Number 1, number 2, number 3, number 4. Okay. Okay, let's say this a simple question. Okay, find the safety factor respect to bending for gear number 4. For gear number 4. Okay, so we start from this equation. Okay. So SF, page, just go to page 55. Okay. So this is the equation. So what is ST? You can refer to slide 38. What is YN? 47 KTKR. Okay, slide 52. Okay, what is it? Okay, you can go to this one. Okay. And then later on, okay, how to find sigma? Okay, sigma in the slide 18. Sigma equal to, okay, this one, WT, KO, KB, KS, PD, F, KM, KB, J. Whatever, what is the meaning of those symbol? Okay, so is being mentioned there. WT using this equation. KO, slide 19. 2021, 22. PD over F. You should know this one. What PD? What F? Apa itu F? Anybody? F. If you can't remember, go to part 1. FF is a phase width. Phase width. Phase width. It's on the part 1. It's very simple. You start from here and then we can explore all those value to solve the safety factor. Similar to the case of, let's say, find the safety factor respect to pitting for gear, let's say for gear number 2. So go to pitting. This per gear for bending. The next page is page 56 is per gear for pitting, or this slide you wear. Okay, similar. Okay. Where? Okay. Right. And then this is the equation to find the safety factor. Okay, what is SC? page 43, 46, ZN48, CH49, KTKR similar on this slide 52. And the difference is on the sigma. Stress equation. So slide 13, 14 to find the CP, WT, KO, KB, KM, and so on. Okay, very simple. This is that's why it's called as a roadmap of gear analysis. Using this one slide, you're able to solve the safety factor. All right. Okay. So settle. Settle about some explanation about this gear part 2. Right. Okay. I hope everyone clear. All right. Okay. Now is the process of to understanding how we going to solve this problem. All right. Let's say we're going to calculate the safety factor. Okay. The question. Okay. Let's say today we're going to. Okay. Let's say this one. Okay. Let's say question number 1. Okay. Find the safety factor. Factor of safety. Okay. Of gear. Okay. Safety of T for gear 4. Gear 4. Okay. For gear number 4. Okay. Respect to simple. Respect to one bending and second one fitting away. Okay. All right. Okay. So let's do together. All right. So we're going to find the SF. So the SF just refer to this page. Okay. All right. Okay. First step, we're going to find what is ST. It's easier. What is find the ST? Okay. So what is ST? Okay. All right. So we go to slide 38. All right. What is ST? Okay, go to 38. Please someone tell me what is the meaning of ST? Muhammad Shafiq, are you there? Aku punya line putus ke ni? Tak ada orang jawab ni.
Dengar, sir.
Doktor? Ya, doktor?
Syafiq, okay. Ada berapa Syafiq ni kat dalam ni?
Tak tahu, doktor.
Satu lah kot, kau seorang je yang jawab.
Mungkinlah.
Syafiq, okay. Tell us, what is ST? Biasanya kalau saya panggil nama mesti somebody akan ada yang left the meeting. Okay, Syafiq.
Ya, doktor.
What is ST? We're going to find the ST. Okay, our first step, we're going to find the ST. What is ST? gear bending strength. Okay, gear ST is gear bending strength. Thank you for helping Shafiq. Okay, Shafiq,
Ya dokter,
what is ST?
bending strength dokter.
Okay, on which page you are now?
Sorry dokter,
On which page you are now?
saya tak dengar dokter.
What is your page on your notes right now? How do you know ST is what strength? What is ST? Bending strength. Bending strength. Okay. Okay, Shafiq. Your line clear?
Not very clear dokter.
Okay. Which page on your note now? Tak apa. Jauh. Okay, Azmi.
Yes, doctor.
Okay. So what is ST?
Bending strength.
Bending strength. Okay. So you refer to which page right now?
41.
41. Okay. Let's together we move to page 41
Yang ada table tu doktor.
Okay. Okay, very simple. Okay, we're going to find ST. ST mentioned that the slide is start from 38. How do you know ST is strength bending? On which page you refer just now? You got the answer?
Slide 35 doktor.
Huh?
35 doktor. 35 36.
35.
Yang tolong Hazmi Okay. So I hope Hazmi able to find the answer. Hazmi.
Yes.
Okay. So if you go to page 38, okay, let's say mention about 38. Go to page 38. Alright, 38. Okay. So we can see there. Okay, nothing information. Maybe you can go more page. Okay, scroll again. Alright. And 55 ST is the gear bending strength. Okay, gear bending strength. Alright. Alright, so it's from 38. Okay, so the information about gear bending strength is from 38. This one maybe we cannot find anything. Oh yeah, still not much information. Okay. So from 30, okay. Okay, 38. Okay, you can see there. Okay, we're going to find the ST value information we should know. Okay, if you can see there, there's a chart. Can you see grade 1, grade 2? Okay. How many equation can you find? Siapa dia nama dia? Azim Azmi. Okay,
Equation kat
Azmi.
38 tu
Yeah, if you refer to page 38, how many equation can you see to find the ST? How many equation?
Hmm, tu
Two, which one?
yang grade 1 dan grade 2
Can you pronounce the equation? ST equal to?
Equal to yang 77.3 HB tu
Okay, my first question is how many equation to find the ST in the
Uh,
38? How many equation?
There's two there.
Okay, which one? Okay, yeah. Okay, tell me the two equation that you found.
First one is 77.3 HB plus 12
Okay,
and
the other one?
PSI. And the other one 102 HB plus
Okay.
16.
So you only can see two equation.
Yeah,
Alright.
on the 38.
Okay, actually, if you refer, if you open your eyes carefully, there are four equation to find the ST. The first one is this one. If you realize in the table, in the figure, in the table, in the chart, okay, plus 16 unit PSI. Grade 2, grade 1 is 12,800 PSI. That one is the equation if you using English unit. If we using the SI unit is at the bottom. ST equal to 0.533 HB plus 88.3 MPa megapascal for grade 1 and for grade 2. So I hope everybody can see the equation to find the ST.
Doctor.
Yes.
If we doing the calculation, do we need to use both English and SI unit equation?
Okay, good question. All right. To answer your question, okay, now we proceed with this slide. Okay, last week, what is our motto? Our spec of motto?
Five kilowatt,
5 kilowatt
2000
RPM.
RPM,
RPM?
2000.
2000 RPM. Okay, so our problem, okay, for today calculation on a word, okay, we are continue on the last week problem. Okay, so last week our motto is 5 kilowatt 2000 RPM. 5 kilowatt in SI unit, SI unit. All right, okay. Therefore, if you refer to page 38, okay, possible equation is on the bottom. Is using MPa. You can see. So the next question is, which equation we need to use? Is it grade 1 or grade 2? What the meaning of grade 1 and grade 2? What does it mean? Anybody got any idea? What the meaning of grade 1 and grade 2?
No idea, Doctor.
Okay, grade 1 and grade 2 is referring to ST is the gear bending strength. Gear bending strength. So the grade 1 or grade 2 is referring to gear, the material of the gear, the material of the gear, the material of the gear. Okay, so I show you an example. So I refer to the group project. Actually, I want to focus on the table of gear, gear, catalog gear. Okay, try. Okay, let's say I would like to find the same as any. Okay, all right. Okay, this is one of the catalog for gear. Right. Okay, can you see? If you refer to catalog of the gear, okay, specification. Can you see precision and grade? Okay, okay. This gear produced using JIS standard grade 1. JIS standard grade 1. All right. So grade 1. Okay. So if you want to find the ST, so you have to know grade of gear. Grade of gear. Okay. Grade of gear. So basically, this information is given. Given. Is given. But in your project, okay, in your project, you need to refer to the catalog. You need to refer to the catalog. What is the grade of the gear that you select? All right. Okay. I hope that's clear. Okay. So let's say in our case study using gear grade 2, grade 2 steel. Using steel grade 2. So therefore, if you refer to this page 38, so the equation is 0.7. Can you see 0.703? Okay, HB plus very structured. Okay, 113 megapascal. Go. So this is for the case of grade 2. Remember, for the case of grade 2. Alright. If our problem is on the grade 1 using grade 1 gear, so you need to use the other one, 0.533. Alright. Another information you should know is what is HB. Anybody? Remember what is HB? What is HB? Ada yang tak? Brittle hardness Okay, thank you. Okay. Again, where to find the HB? Which one? Oh, okay, all right, okay, good So HB is referred to brittle hardness, brittle hardness. Okay, brittle hardness. Okay, brittle hardness. All right. Okay, similar to information about grade 2, normally in question during your test, this value will be given. This value will be given. Okay. But in your project, how to find this HB? Go to catalog. You can see here, hardness. You can see here, this kind of gear using grade 1 and the hardness is between 55 to 60 HRC. So you have to convert lah HRC to HB. You have to convert lah. Just Google 55 HRC to HB. So 55 HRC hardness comparison. Okay. Convert lah ni. Gunalah ada table. You dapatlah jawapan dia. Okay. Let's say in our case, in our study, okay, let's say I dah share lah, let's say okay, contoh lah grade 2, let's say this is grade 2, okay, let's say 50 HRC. Okay. Alright. Hardness Rockwell HRC. Ini formula dia. Okay. Let's say we select 60 HRC What's the value in HB? Cuba kira 17.55 kali 60 tolak 401 berapa? 17.5 kali 60 tolak 401.
649.9.
Okey, berapa jawapan dia? 6
49.
649.
649.
Okey. Okay, so please, what is the value of ST? Okay, so that's how we get the value of HB.
569.2. 569.2.
569.2 megapascal. So that's the value of ST. Alright. Settle ST. So next step. So we refer back again to page 55. All right. Okay, we settle ST. Okay, next we're going to find what is the value of YN. So YN we need to turn to page 47. YN 47. YN 47. Okay, before that, okay. Another way, let's say, okay. Just now, okay. Okay, I will explain this table, page 38. Okay. We just now we calculate using the bottom equation. The top one is if we use in inches in English unit. Let's say for example, our hardness is 200 HB, 200 HB, and then okay, and then we use grade 2. Grade 2. Okay, so we just straightly go and then crossing on line grade 2, and then you turn to the left, and then you can find the value of ST in unit KPSI. That's how you using table lah. There are two ways. Means that if you calculate using this equation, you put the value of HB, and then you compare using the table, you will get the almost similar value lah. Right. Okay, so again, 38, you have to be careful. Okay, 38 is for load bending number for hardened steel. 39 is for another type of material, which is nitridate hardened steel. Give example of AISI and so on. 40 is for nitriding steel. Okay, another type of chrome grade 1. Okay, so you have to aware the material. So different material give you need to use different equation. All right. Okay, just now back again to YN. YN is on the page 47. 47. Okay, YN. Okay. So this is YN. YN. Next step, we going to find the value of YN. YN. Okay, YN. Okay, YN only referring to page 47. Okay. So if you can see, okay, there's a lot of equation. Boleh pening, mabuk boleh tengok ni. Mana satu nak pakai? Alright. Okay. YN, okay, YN. Normally YN is referring to the what is our load cycle. Load cycle. Load cycle means that our operating of the gear system. Is between 1000 or less, more or less. Okay, that's one thing. And also you need to know what is the hardness. Just now our hardness is 600 something. 600. Okay, 600. Okay, is more than the maximum line is for 400 HB. So 600 is beyond. All right, it's beyond. Okay. So in your okay, as I explain first how you define the equation to use. So it's referring to the level of hardness and also the number of cycle. Okay. So in your project, you have to define first what is the load cycle. Eh? What is the load cycle? And then by define your load cycle, let's say 1,000, and then you can decide, let's say 1 million, 1 million somewhere here, okay, maybe somewhere here, and then referring to the number of hardness, so you can decide lah what is the suitable equation. But let's say in the in the in in our calculation in during test test 2, normally is it will given. So let's say we use the equation is given, so let's say yn equal to, we select the 6.5. Okay, let's say sorry, so our material is more than for, let's say 1,000 is more than let's say we decide 1 million is more than 400, so the highest is this one. So no worry, normally is given. So but in our case, we decide to use 9.4 4518 and to the power of minus 0.148. All right. Okay. So in this case, let's say okay, let's say our setting number of load cycle is 1 million, 1 million. So our N here, okay, we setting, we set is 1 million, this one. So can you please calculate what is the value of Yn? Yn unit numberless. Okay. So please calculate.
One point two to three, sir.
1.223.
223.
Okay, 1.223 for our Yn. Okay. Right. Okay, thank you. All right. So what's next step? Then we refer again to our main slide. Okay. ST, YN, KT, KR. KT, KR. Okay, go to page slide 52. Right. Okay. KT and KR. KT is the reliability factor. Okay. So KT is reliability. Okay. Okay. Again, in our project, you as the designer, you set what is the reliability of your design. Okay, let's say you put 90% reliability. Let's say 90%. 90% reliability. So from table, the value is 0.85. Alright. Then KT. Alright. What is the definition of KT? Okay, operating temperature is less than 120, so the value is equal to 1. For higher temperature, heat exchanger may be used to ensure that operating temperature are considerably below this value. Okay. So in our simple calculation, I think in normal operating, we not operate more than 100 degrees Celsius. Okay. Okay. So therefore, according to this statement, our KT is equal to 1. Correct. Okay. Settle. So again, so to find the safety factor respect to bending, okay, respect to bending here. So the final equation is ST and okay. So we divide by KT over KR. Okay. Sorry. Not KT over KR, KT times R. KT times KR. And then divided by sigma. Okay, so we settle to get all those value. And I already explained to you how and what is the meaning on how we're going to find this value. Okay. So far, is it clear? Any questions so far? Blur? Confused?
Doktor, yang KT 90% tu patutnya dia KR, doktor. Doktor salah tulis.
Okay, sorry. Alright, thank you. KR Okay, reliability is KR reliability is KR. Thanks. Alright. Okay. Kalau ayat biasa penjara saja saya tulis salah. Nak tengok student alert tak kan? Hidup ke tidak? Okay. Itu ayat biasa lah. Alright, thank you. Alright, so clear STYN tu apa? KT, KR. Alright. Okay. Alright, then so what's next step? Apa step seterusnya?
SF tak dapat lagi ke? SF dah tak dapat lagi kan?
Okay. Okay, what is our aim? Saiful.
Cari SF lah.
SF. Okay. So the equation of SF is this is the equation of SF. STYN.
Okay, I see.
Alright. So safety factor or factor of safety. Find the safety factor. Again, we're going to find the safety factor. This is the equation. This is the information. This is the question. Find the safety factor for gear 4. Remember? For gear number 4. This one. Ni. Dia punya gear sini. Kita nak tahu ni. What is the safety factor of this one? Okay. Okay, Saiful eh. So what's next step, Saiful?
Cari tu yang bawah. Apa
Dia.
apa bentuk?
Sigma.
Sigma.
Habau. Oh, Melaka cakap lah. Okay, Sigma. So next step is we're going to find the Sigma. Sigma. Okay, going to find Sigma. Right, as I write down just now. So finally, we need to find the value of sigma. Right. Ini kan? This is our main equation just now. So new page. We're going to find the sigma. Saiful, kau orang mana tadi? Kau asal mana?
Sampai mana?
Siapa? Asal orang mana?
Perak.
Perak. Okay. Sorry Ayub. Kasar bahasa tadi. Ingat orang Melaka. Okay. Okay. Sigma. Okay. There are two equations to find the sigma. The first one, if you can see, gear bending stress equation. The other one is gear bending endurance strength equation. This sigma is referring to which one? Issue there.
Yang belah kiri doktor, sigma yang WTKO lebih panjang.
Sigma is referring to bending strength, bending stress. Okay. All right, good. So it's on the slide. Itulah, page 18. Page 18. So we go to page 18. All right. Page 18. All right. Okay. So we are looking just now for, okay, so bending. Okay. Remember, we are on the bending lagi. We are focusing on bending. Bending punya safety factor. Bending. Right. Bending. So if you refer to page, our main page is slide 18. Page 18. Page 18. Page 18. Okay, this one. Right. Okay. So if you're aware, there are two equations. So it's referred to either SI unit or English unit. SI unit or English unit. Okay, the explanation about the symbol is there. WT tangent transmit load, KO overload, KV dynamic, KS size. Okay, in our case, we are focused because just now kilowatt, so we are using SI unit. SI unit. Okay, so we are focusing on the second equation, WT, this one lah, blah 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 blah. So one, the difference is one, phase width, MT apa? Transverse metric module. Okay, module M. Okay, M lah. Module KM KB over J. Okay. KM KB over J. KM load factor, KB thickness factor, J geometric factor. Alright. Power je Alright, so ikut sedap you, nak calculate yang mana dulu? Which value we want to find? Okay, kita nak cari value apa? Value apa dulu kita nak cari? Value mana kita nak cari?
WT dulu Doktor.
WT WT tengok WT. Okay, WT. Right. WT tangent transmit load. Okay. Okay, tangent transmit load. Panjang tu nanti explanation panjang. Okay. Alright. Let's take a few extra understanding. Ujung-ujung ni dah agak yang ngantuk ni Kang. Kita cari yang senang dulu lah.
Dia ada formula Doktor. WT tu.
Yes, there's a formula. You need to go to this kind of formula lah. Okay. So I would like to teach you. We go to the simple one first. Simple one first. Let's say we find K. Start with find KO first. Okay. Let's find KO first. KO. What to find the where to find the KO? Okay, overload. Alright. KO overload factor. Okay. KO overload factor. Okay, we start to find the KO first. KO here. Okay, KO overload factor is defined to our system. System means that is referring to the system is referring to our system, this one. KO. Means that what kind of power source? Power source. This is power source lah. This is our power source. In your project, you define your power source. Let's say we use motor, electric motor. Okay. If we design, we use electric motor, okay, so the power source is considered uniform. If you select the motor using internal combustion, that one under light shock. Similar goes to single cylinder internal combustion engine is considered medium shock. Okay, so go to the next. Okay, what about uniform? if a type of generator is centrifugal compressor, fuel liquid is a moderate short is you are using a kind of multi-cylinder compressor, liquid solid. Heavy short if using this kind of rolling miller, power shovel, and so on. Okay, this kind of information. Okay, when you I would like to explain in terms of project. In your project, if you select the motor, type of motor, there will be more information about the driven of the machine. Is it centrifugal? Is it main driven? Is it multi-cylinder compressor or this one? So let's say we use the motor, very simple motor, electric motor, and is using centrifugal. So this is under consider uniform and uniform. Okay, so uniform and uniform. So the KO value is equal to 1 for the case of uniform and uniform. Uniform and uniform. But so this kind of information in the test should be given. Should be given. So you need to read carefully. The motor, for example, the motor is using electric motor. The motor is using electric motor with the type of centrifugal compressor. And then you go to table, find the keyword, and then you know the value of KO is refer to that sentence lah. Is it clear? KO?
Clear, Doktor.
So next is to find the KV. Just now slide 19 kan? 19 to find the KO. Next is to find the KV. KV, the next slide 2021. 2021 to find the KV. KV. Next we find the KV. Okay, KV. Okay, what does it mean KV? KV is called a dynamic factor. Apa benda ni dynamic factor ni? Right. Okay, the keyword here is quality number. Okay, quality number. Okay. Akmal has defined set quality number and blah blah blah. Baca tu So it's referred to the quality number. Dynamic factor keyword here is the value of quality number, QV. It's referring to the what is the QV, quality number. Quality number. Okay, if you can see here, 3 to 7 is to the process of producing QV. This is the process of producing the finishing of the gear, the quality finishing, the quality of finishing. Okay, means that if you use precise, the high end is very very good quality. So the QV normally is between 8 to 12. So if you use the commercial quality gear, between 3 to 7. 3 to 7. 3 to 7. Okay, so normally again, this value is given lah, given the question. Okay, so normally we use commercial lah, select commercial. Budget siput, we use the commercial. Biasanya kalau precision quality, the high quality, the price higher. Commercial, we don't need to use the precision quality. So catalog and say definitely we use meter per second, because SI unit. Okay. So the first step is we need to find the nilai A and B. Okay. So can you find the KV value then? Find the KV value. See how you can understand. 5 minit, 10 minit, 10 minit, sekali lagi.